Okay. Hi guys. So today we are going to see about Ollama, which is a tool helps us to deploy or run open source LLM modules like Llama 3, etc. So let's see which are the models available using Ollama. And this is the steps to install Ollama, so we can run Llama 3, 5.3, Mistral, Gemma, and many other models locally in our systems. So for that, first we need the Ollama. So we need to install this in our local system, or we can use Docker. So if we see in the official repository, they have given the steps to install the Ollama. So we can directly install in macOS or Windows or Linux. So currently we can prefer using Docker to run it as a container. So I prefer to use Docker. Let's see the official image of Ollama. Okay, this is an official image, and here is the command to run the Ollama locally, which pulls the image from the repository and runs it locally. And we see here port mapping has been done so that we can hit the container using this particular port from the host machine, which will be mapped to the container port. So let's just copy the command, docker run command, and I'm gonna run it. So this pulls the image from the repository and it's going to run the container. Okay, let's just check whether it is started. Yeah, container has been started 10 seconds ago. Let's get into the container. So I'm using docker exec command to exec into the container, and we can target shell script inside the container since it will be built upon some Ubuntu OS. So let's check whether we are into the shell script. Yeah, we are into the shell command prompt. Okay, now let's get back to the repository. And so we're gonna choose two models today to deploy it locally. So first thing, we can try Llama 3, and for simplicity we can take 5.3 mini, which has like 3.8 billion parameters, but Llama 3 has 8 billion parameters. And you should be aware of the requirement to run these models in your local machine. So you should at least have 8 GB RAM available to run 7 billion parameter models, or if you're going more than that, like 13 billion parameter model, you need at least 16 GB to run in your local machine accordingly. So currently I'm choosing Llama 3, which has 8 billion parameters with size up to 4.7 GB. So for that I'm going to copy the command, which is Ollama run Llama 3. So we are going to run this command inside the container. So this command is going to pull the Llama 3, which is 4.7 GB, and it's going to start it. Okay, since I already ran it once, it's already there in the local, so it downloaded it as soon as possible. So that now we can try to interact with Llama 3. Let me ask, what model do you use? Okay, we are able to see the response from the LLM, which is running locally inside the container. So usually we can also install it locally in our system without using Docker image, which some people will prefer. But if we use Docker containers, we can delete it whenever we are not using it. And for each container there will be volume attached, so that whenever you download it once, it will be there in the volume, so that if you start the container again, it will use that volume as attached to the same container again, so that you don't want to download it again and again when you want to run a model in your locally. So let's see what commands are available in Ollama. For that, I'm just using /help. So these are the commands available. So if I want to exit, I can use just /by. So that's it. We are out of the so the model is, we are not interacting with the model anymore. We came out, but we are still inside the container. So let's try to pull in another module inside the same container. So let's go back to the repository and let's pull up the next model, which is 5.3 mini. I think the 5.3 mini is developed by Google, and it's also a lightweight. It has only 2.3 GB and it has 3.8 billion parameters. Okay, let me copy the command and okay, it's already there in my volume, so that it's not downloading it again. I was able to start it as soon as possible since it's already there in my volume, which is attached to the container. So let me ask the same question which I asked Llama 3, so that we can compare between those two models. Okay, I'm seeing the response from 5.3. Okay, I was wrong. So it was developed by Microsoft, not by Google. So the 5.3 is developed by Microsoft. Okay, so we are able to get response. Let me check again the help, and I'm going to close the chat. Okay, we were successfully able to run the LLMs locally using a Docker container. Okay, so now let's try to customize the model and use it however we need it. And so that for that we can refer the documentation in the Git repository. So we have a section called customize a model. So for that we need to write a model file. So the model file will use the base model, which is we can use whatever model we want. For example, here it has given Llama 3. On top of that, we can set the parameter. So this parameter helps us to decide how to tweak the model, and we can set the system message. For example, for what the model has been used for. For example, here we can see it is used as a Mario. So Mario from the Super Mario Bros. And it will answer as Mario. So if you say hi to this model, it says I'm Mario from Super Mario Bros. And it will start your conversation and answering it in the perspective of Mario. So we can customize a model however we need it. So we'll just copy this, and I have it in my VS Code already, and I've changed the message a little bit. So I wanted to have my own customization. So if you see here, I have changed it as you are a customer support for a company called Kefiab. Answer as Agentina, the assistant only. So the chatbot is going to assume it as Agentina, who's a customer support for a company called Kefiab. So let's build this model and then try to run the model, and let's try to chat with that model and see what it happens. Okay, for that I need this file. I'll just copy this, and let's try to create a file called model file. This is the format to create the file, but since we are inside the container, we will not have the basic tools like vim or sudo. So that let me first run apt update. It will update the packages, and I need vim apt install vim. Yes, I wanted to install it. Okay, now we have vim in place. So let me just create a file called model file and open it with vim, and I'll just paste it. So now here we have the model file in place. Let me save it. So to run the model file, to build the model file, we have a command Ollama create and a name for the model and the model file. So I wanted to change the name, which is I'll change it to agent. since I'm creating a model for a customer support agent. So I'm going to run the command. So this is going to build my custom model, and it's done. Okay, now let me interact with the model by running the model. For that, the command is Ollama run model name, which is agent. So this is a use case, one of the small use case where we can customize existing open source LLM models and customize it according to what's our use cases and what's our requirement is, and we can even provide more information to that particular model to answer according to the data, so that the model will respond using those data, so that we can customize the model however we want. And then now the agent, we started the agent. Let me say hi and see what the response is. So we got a response stating that welcome to KFIA customer support. My name is Argentina and I'll be happy to assist you with the questions or concerns you may have. So this is typically answering in a perspective of customer support of a particular company called KFIA. So like this, we can customize open source LLM modules however we need. Okay, let me exit it. Okay, now we are able to interact with the model inside the container, but in real world we doesn't want to interact. We doesn't want to get into the container to interact with the model. So for that, Ollama has its own REST APIs exposed. So we will be able to access those REST APIs using curl command, which is running in localhost. As we talk about the port mapping when we ran the Docker image, so the port is mapped to 11434. So this 11434 port from the host machine will be mapping to the container port, so that we'll be able to hit the container and get the response. Let's try this by exiting the container. We'll just exit the container out. So now we are in the host machine, and I'm going to hit the container using a curl command, hit the API, REST API, and I'll ask for create a sentence using the word LLM. Okay, let's take LLM. Okay, now this should hit the containers server container, and it should give us the response. We are able to see the response, and if you see, it has model, which model it used and created at, which gives the timestamp, and response word by word, and for each word there is a parameter called done, which says false, which means the response is not yet done. So finally, when we get the final word of the sentence or the whole response, we will get it as true. We can see it here. So we are successfully able to hit the custom module which we built, which we ran in our container, which is not the custom module, it's just Llama 3. Okay, let's try to hit the custom module which we built. For that, we just need to change the curl command by selecting the custom model which we built, which is named as agent, if I'm not wrong. It's agent, and let's try to ask. List me services provided by KFIA. Okay, I'm getting the response from the custom module which we built using a model file, and it says hello there, and then it introduces itself by saying that a customer care named Argentina, and it gives the list of services provided by the Cafe Hub. Yeah, by this way we can run the open source LLM modules locally, and we'll be able to hit the REST APIs also by using Ollama, which is a powerful tool, I would say. I'll also be attaching the GitHub link in the description if you want all these commands and wanted to explore, and you can use the GitHub link. So going forward, I'm thinking to create another POC kind of a project using these custom models. I'll be posting my next video soon. Yeah, it's keep on giving a response. It's just listing the services provided by the company. Even though we didn't give the context of what the services provided by the cafe private, it's giving the data from by its own, but we can provide those details when we build our custom model using the model file. If we are able to provide those details also, so the details will be as accurate as possible, since we have given the data what the company does and who are the customers and what are the services it provides. So now for now it's like giving the answer by its own, but in the perspective of a customer care service. Yeah, that's it. We are able to see the response. So we can also compare both two models and see how the response is been differing between those two models. So currently we choose Llama 3 and Phi 3. Let's try to hit those models with the same. Let's get into the container. This doesn't seems like it's not readable, so for it to be readable, let's get into the container. Docker ps, which gives the container id, and docker exact -it container id, and I'm going to hit the shell script. Now let me run Llama 3 first. For fun, we'll try to ask the model to write a song about LLMs, and let's see which model gives better lyrics. Write a song about LLM. Next we will try with Phi 3 model, and let's compare which one is better. The digital rim, they are making waves. Generative minds with knowledge they care. Yeah, it's interesting, but it's pretty much slow, like it's going word by word, because my host machine compute, it depends on the compute power, how much you have in your host machine. So it depends on how powerful your laptop is, and it also depends on the lightness of the model. Llama 3 is a bit heavier than the Phi 3, so you will see a drastic difference in the speed when we use Phi 3 model. Next we'll be using Phi 3, and we can see how fast it is, because it's a lightweight model which is developed by Microsoft, and they have their heavier model too, which is Phi 3 medium. So we are using Phi 3 mini, which is just 3.8 billion parameters. So when these parameters increase, the weight of the model also increases, and it requires more compute power, as we saw the requirements of memory for each parameter types. So the difference between the two models which we selected, the first one, Llama 3, is 8 billion parameters, but the Phi 3 is 3.8 billion parameters, which is less than half of it, and it's just 2.3 GB. Let's see whether it is done. Not yet. I think it's in the last paragraph. There are many AI tools to convert this lyric into a song. We can use those tools to create song using this lyric and just see how it is, just for fun. Okay, it's an outro, which is the last paragraph. I think it's almost done. Yeah. Yeah, it's done. So now let me get out of Llama 3 and I'm going to start 5.3 mini. And I'm going to ask the same exact question. I write a song about LLMs and let's see how fast and how different it is from Llama 3. I can see that it is pretty much faster than Llama 3 and it's very visible too. Since it has less parameters, it's faster than Llama 3. Going forward, we'll be deploying these custom models in a Kubernetes cluster and try to play with Kubernetes and deploy these custom models, and not only basic custom model, and we'll try to customize more and try to deploy those models into the Kubernetes cluster in upcoming videos. Okay, I think it's almost done. I see similar words from both the models. In some lines I see similar words. Digital RAM, and I see the same digital RAM here. No, it's none of artificial. Okay. Yeah, it's totally different. Yeah, after this completes, like, we can try to I'm not going to do that in this video, but you guys can try using this lyric into some AI tools to create a song and try to play it and see which one sounds better. Yeah, it's done. Okay, that's it for this video. We'll try to deploy this model in a Kubernetes cluster and try to deploy it in Google Cloud and try to access from the browser, which is more interactive way, and we'll do that in next video. Thank you guys. Thank you for watching this long. We'll see you in the next video. Bye bye.